Let's take a look at oscilloscopes. This is oscilloscopes. I want us to know that one thing about electricity is that we know that electricity has to do with the flow of electrons in electrical circuits, and we know that from the knowledge of atom, it's made up of components. We talk about the proton, the neutron, and the electron, and this electron is what flows in electrical circuits. And but I want you to know that we cannot see the electrons the way it is flowing in electric circuit. But when you talk about oscilloscopes can give us visually what the signal looks like. So it can give us what the signal looks like, and therefore when you look at an oscilloscope, is a measuring equipment or instrument that graphically displays electrical signals and shows how those signals change over times. And these oscilloscopes, they comes in different shapes, they come in different sizes as well. The one I have here, this one is digital oscilloscopes. We also have the analog oscilloscopes as well. So I'll be using these digital oscilloscopes for the purpose of this tutorial. Now let's take a look at, for any oscilloscopes, these are very essential. This is the front panel that display the output of the quantity that is being measured, and this is the power button. You can power it on or you off it depending on what you want to do. And here I have channel 1, I have channel 2. So this is just 2 channel oscilloscopes. You can have 4 channel oscilloscopes as well. So, and here I have the this section is what we call the ground. So for the ground, and here we have for external trigger, and this is time division knobs. Here I have the for voltage. This one is for voltage as well for channel 1. This one is for channel 2. And not that alone, we also have a couple of we have time divisions, and we also have voltage divisions. We have a couple of buttons here that we can use to carry out that can help us when we are using our oscilloscopes. You have a couple of them. Whenever you want to use your oscilloscopes, the first thing you need to do is to press the default setup buttons. That's the first thing that you need to do. And not that alone, let's take a look at a couple of connectors and sockets that can be used with our oscilloscopes. Now, talking about the connectors and the sockets, as we have in the diagram of oscilloscopes in this slide 27, we can see that here we have 2 input channels to receive the signals. We have what is called the channel 1. You can plug, like for instance, now if you want to check the waveform of the input signal, you can use publish channel 1. Then if you want to get the waveform of the output signal, you can use channel 2 for that, and the two waveform will be displayed when you are testing, be it electronics panel or any electrical circuit. So it will give you the waveform of that signals, and you can then analyze the wave and know the situation of that signal. So that's talking about channel 1. This is channel 2. So where you can plug in any of what you want to plug. Then that is talking about the 2 input channels to receive the signals, channel 1 and the channel 2. Then we have a port to signify the ground. As I've said, this port is used to signify the ground. And then not that alone, we have an input to receive an external signal to act as a trigger source. That is external trigger. That is talking about this port that I've just said here. That is this port. And not that alone, we have channel 1, channel 2, and external trigger all receive signals via the BNC cables, with each port having a BNC connectors. Now, talking about the time division settings, as we can see, the display of an oscilloscope is typically graphs along its axis with a fixed grid of 1 centimeter squares with minor divisions 0.2 centimeter apart. And the time division knobs controls the scaling of the x-axis, so that the different amount of the time are represented per square. For example, a setting of 5 seconds per division means that each 1 centimeter squared display along the x-axis represent 5 seconds of time. And not that alone, we take a look at the volt slash division settings. That is talking about the display of oscilloscopes, as we have said earlier, typically grabs voltage along its y-axis with a fixed grid of 1 centimeter squares with minor divisions 0.2 centimeter apart. And they're looking at that, the volt slide division knobs. These knobs control the scaling of the y-axis so that the different amount of the voltage are represented per square. For example, a setting of 5 volt division means that each 1 centimeter square displays along the y-axis represent 5 volts. And they're not that alone. We have ACs like DC ground settings, and such switches, as we can see, can be set to be either AC, ground, or DC input, and are typically located next to the input channels B and C connectors.